All right, guys, tonight we are going to talk about linear transformations. So, a transformation is simply a change in position or size of a figure. So we know all by figure what we've been talking about lately are lines, linear equations. So we're going to look at some examples of some linear equations tonight, and we are going to see how changing the slope and the y-intercept affect what the graph looks like. So let's go ahead and get a definition down in our journal. A parent function is the most basic function in a family. Okay, so right now we're studying the linear family. For linear functions, the parent function is y equals x. Remember that we can also write y equals x as f of x equals x. Remember that this right here, f of x, is just function notation. So you could see both of them, they're the same thing, but y equals x is our most basic parent function, and that's what we make all of our changes to. So we either add a slope in front of the x or we add a y-intercept after the x, but we start with the most basic y equals x. So what we're going to do right now is we're going to look at our equation in slope-intercept form, y equals mx plus b, and we are going to use Desmos to determine how this b right here affects what our graph looks like. So let's go ahead and pull up Desmos here. And as you notice, we're going to look at this red line right here. So our line has a slope of 1, okay? Our b, I should have gotten ahead and had this ready for you guys, has a slope of 0. Right now the y-intercept is 0. Notice as I slide this along here, the y-intercept, the b value, is increasing. And what's happening to the red line? It's sliding up, 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 up. So it started way down here at 0, and it's as the y value, the b, has gotten bigger, the graph has gone higher on the y-axis. Notice if I go in the negatives. So if I start at 0 and my y value is negative, my b, my y-intercept, notice I'm going to go down. The graph is going to get further down, 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 down as the y-intercept gets smaller. Okay? So what can we say about the value of b? The value of b shifts or translates the graph up or down. Okay, so whenever we talk about a couple equations here, like y equals 2x minus 4, and then let's compare that to y equals 2x plus 6. So notice the slope is the same, but what's different about these two is the y-intercept. In my first equation here, my y-intercept is negative 4. In my second equation, my y-intercept is 6. So here, I'm starting at negative 4. So if I go back to my graph, I would start at negative 4. Okay? Now, my second line, it has a y-intercept, we said, of 6. So the graph is going to go from negative 4, which is right now, up to 6. There it is. What just happened there? There was a shift. And what kind of shift specifically? The graph shifted up how many units? 10 units. It went from negative 4 to 0, which is moving up 4. Then it moved up 6 more. So we say the graph shifted up 10 units. Or another way of saying it is the graph translated up 10 units. Does that make sense? Okay. So the b controls the graph translating, shifting, moving up or down the y-axis. Let's look at the next one. The next transformation that we're going to look at is changing the slope. So let's go back to Desmos and let's look at, here my red line has a slope of 1. I'm going to move my y-intercept back to 0. And now I'm going to get this blue line into the game and I'm going to make it have a slope of 1. Notice when it has a slope of 1, I have the same equation, so they're right on top of each other. Now, if I change my blue line, and if I make the slope of that line, as the slope is getting bigger, which is my a value, as my slope is getting bigger, what's happening to my line? It's getting steeper. As my slope is getting smaller, now I'm at 4, moving down to 3, 2, 1, the line is getting flatter. Okay, so that's important to note. The bigger the slope, the steeper the line. Okay, the bigger the slope, the steeper the line. The smaller the slope, so if I start way back up here at 8, and I'm going down, the smaller the slope, as the slope's getting smaller, the line is getting flatter. Okay? So let's go ahead and move what's under here and write that down. The M affects the steepness of our graph. The larger the slope, the steeper the line. The smaller the slope, the flatter the line. Okay? So make sure you write that part down. Now, let's take a look at the next thing, which is what happens when we add a negative to our graph. So if I have y equals x, that is a slope of 1. Remember, we can write that y equals 1x plus 0 is how we write that. We write this one, y equals negative 1x plus 0. Okay, so those are the same thing. So if I have, let's look at what difference that makes. So if I have my red line has a slope of 1, y-intercept of 0. Now my blue line, I'm going to make that have a slope of negative 1. There it is. What do you notice there? Now my blue line is going downhill. It's a negative slope. What do we notice about the steepness? The steepness is exactly the same. Okay, so the negative, all the negative did was it caused a reflection to occur. Okay, so the negative in front of the slope causes a reflection across the y-axis. What else do we know? That the negative in front of the slope has no effect on the steepness of the line. Okay, so if I have a slope of 2.8, notice that my slope of negative 2.8 is going to be the exact same steepness. Okay, those lines are the same steepness. One is just a reflection of the other. Okay, now, so what you want to do when you're comparing which lines are steeper than the other is you want to take the absolute value of the slope to determine the steepness. So, for example, if I have two equations here, y equals 2x minus 5, and then I have y equals negative 4x plus 7. Let's talk about what happens. Well, here, y equals 2x, that has a slope of 2. Y equals negative 4x plus 7 has a slope of negative 4. But the absolute value, so we're going to take the absolute value, and we get a slope of 4. Okay? So we are now comparing a slope of 2 to a slope of 4. Okay, absolute value of negative 4 is 4. Which one is bigger? The 4 is bigger. Therefore, y equals negative 4x plus 7 is steeper than y equals 2x. It's steeper because 4 is bigger than 2. What else do we know is different? The one slope was positive, the other was negative. So there was also a reflection. So the graph was reflected. To get from y equals 2x minus 5 to y equals negative 4x plus 7, we had to reflect the graph across the y-axis. What else happened? The equation started out with a y-intercept of negative 5, and it moved to a y-intercept of 7. So we know that y-intercept affects the graph moving up and down the y-axis. So to get from negative 5 to 0, we have to move up 5 units. To get from 0, to 7, we have to go up 7 more units. So 7 plus 5, we get 12. So the graph translated up 12 units. Does that make sense? So 3 things happened. The graph got steeper, the graph was reflected, and the graph translated up. So make sure you have all of these notes written in your journal, and we will practice when you come to class tomorrow.